If you look at automotive, you've got things like the radiator grills, you've got assembly components, bracketry, all those sorts of things. It's not just looking at flat product, because you've got other things that are in there that start life as flat, then become bent.
Hello and welcome to another MTD podcast. Today we're going to be talking about several different aspects of machine technology, laser technology, laser cutting technology, punching technology, bending technology, and additive technology, all from Prima Power. I'm joined by two people today. First is a special guest, which is Barry Rooney, and he's from Prima Power. Welcome to the show, Barry.
Thank you.
And also, I should say, another special guest, Lyndsey, as well.
I'm not so special.
Guest. Welcome to the show, Lyndsey. Are you keeping all right?
Yeah, really good. Thanks, Paul.
Good. Now, we've done some technical corners this morning here in the studio where we've looked at every aspect of what we're going to discuss in today's podcast. And it really is, you need to stick around and listen to this because some of the things we're going to talk about have evolved so much in recent years. So, as I said at the start of this, we'll talk about laser cutting, we'll talk about punching machines and punching technology, the bending technology, so things like press brakes and panel benders, and also what's reasonably new to Prima, which is now Prima. Additive is the additive manufacturing technology. Be right me saying it's reasonably new?
Yeah,
Barry?
within the last few years. Yeah.
Within the last few years. Because, I mean, additive technology is coming on massively, isn't it? Leaps and bounds. Yes, yeah. And the synergy between the processes that you offer is obviously quite clear as well. So firstly, before we get into the technology stuff, Barry, just give us a quick overview of Prima Power or Prima Industries as a group, what you do and how long you've been there and what you do at the company.
Okay, so basically the Prima Power or Prima Industry Group is a very large global organisation. We've got 8 factories, R&D centres around the world. We're on just about every continent. And as you've said, we do a huge range of machinery. We design and manufacture ourselves, so there's a lot of the componentry, the electronics, the software, they're all our own products. So it's a very large global concern. As I say, it's owned by the Prima Industry Group, and then we have subdivisions, Prima Power being one of them. Then we have Prima Electro, Convergent, Laserdyne. So yeah, a very, very big, well-evolved company. In the UK, we are one of the wholly owned subsidiaries globally, and I basically head up the sales side of things. And we have, from a UK standpoint, we also have our own service and our own field service team and spares. Support and everything else that goes with that.
Which are critical factors, which we'll discuss as well. Lyndsey, you've been listening in and been doing some of the technical corners as well with us today. Are you quite impressed with what you've heard from
know
Barry?
what? I was actually going to interject then because I am fascinated to hear about a company that does everything in one. I'm not saying absolutely everything, but what I'm saying is all of these different technologies, and they've grown from one another, they've diversified from one another, and then you've just expanded and you do everything, and all the way right down to the end of the automation side of things. So it's a case of you can literally leave your machines just to keep going and going and going, working away. You don't really need very much human intervention, and you supply everything from your own company. And I think that for me has blown me away from Prima Power's perspective.
I mean, I've seen at a few exhibitions around the world. We've done quite a few videos on stands around the globe, and the equipment is always awe-inspiring, you know, the speed of it, and the level of investment that they put into the trade shows we go to as well, where they have, you know, their latest machines, some of which we'll talk about shortly. So from a marketing perspective, they do exceptionally well as well. Let's talk about the laser technology, laser cutting technology to start with, because you've got, in essence, we're talking 2D and 3D here, fibre and CO2. Perhaps you could just briefly explain the differences between the 2D and the 3D.
Yeah, okay. So the 3D is multi-axis CNC. So that's designed around, if you want to sort of broaden or give it in more of a layman's terms, 3D is about parts. It's about welding or laser cutting parts. That's something that's got a volume to it and not just a flat piece. And that's where the 3D machines come in. So if you take an example, say, for the automotive industry, where beneath the skin of your car, you've got a frame and a structure, that's the sort of thing that would be done on our 3D machines. Or, for example, a vessel or something like that.
So you've kind of got the head that dances, shall we say, around it at different angles, and it's working on it, welding or laser. all at totally different angles,
Correct.
like a 5-axis machine.
Yeah, and that's exactly it. Yeah, and it has to maintain a position and a standoff, and also an orientation towards the material at all times, which is why it's a multi-axis head. So
what would people be looking for in one of those machines? Because I'm curious as to you talk about an application that's an actual part. You're going to need to consider where you can get to, accessibility with the head and stuff like that, aren't you? Are these all factors, or
yes, yeah.
What comes into play?
So what comes into play? There's several different things. First of all, holding the part. So if it is an automotive part, for example, you've got to be able to hold that. And some of these can have quite complex geometries. So you need to be thinking about the fixturing, and the fixturing is only one part of the loading and unloading. So we, in our 3D machines, we have effectively a cabin with the robot laser head in it, and then how we bring parts in and out of that cabin is also important. So are they going to be mounted on a table? Are they going to be on fixtures that slide in and out on independent tables? Do we need to use half of the cabin while one part is being processed and use the other half for loading, or do we need to bring the tables out? Or do we do something from a rotary point of view where you're loading a car part in, it spins round and goes inside the machine while you unload the part that's just been done? So that's one element of it. The other element of that is the size of the part, of course, because that dictates the size of the machine and how much space we need around it. And then, of course, the accuracy and the repeatability. They're very, very important, because for an automotive application, you've got very, very high volume. You need to have consistency. Those parts have got to be the same from one car to the next, because they haven't got time to be playing around trying to fit geometries together. So the machine has to be able to reproduce accurately over and over and over again. And that in itself dictates the other requirement, that's the reliability.
I mean, you could look at a good example would be like a car door, wouldn't it, I suppose, where you've got lots of contours and shapes and things that you need to cut out. Okay, talk to us about 2D then, simple.
2D is more simple, basically because you're just talking about a flat sheet of material. I say it's more simple because there are idiosyncrasies in that, in terms of how thick is that piece of material, what is it made out of, because you've got all sorts of different grades of materials, you've got all sorts of different thicknesses, and of course permutations between those two. So you need to be able to have a good level of control over the process. You also need to be looking at what you're actually making from a part point of view. How are they all going to fit together on the sheet? It might be that you're making 1,000 of one component, in which case you want to keep them all as close together and minimise the amount of waste, or you're making a kit from one sheet, in which case the same thing still applies. You've still got to get them all as close together as you can to minimise the amount of waste. Then you need to cut efficiently. When you're cutting efficiently, that's going to depend really on material thicknesses and the process management, and also the optical side of things. So, for example, we have different software suites that will suit the different types of application, whether it's a thin material or a thick material. A thin material, generally speaking, what you would want to do is optimize the amount of time that you're out of the material to really speed up the performance.
But the cutting edge, or the cutting technology here, we're talking either fibre or CO2, aren't we?
Yeah.
I know from previous experience with talking to companies in this arena that the areas, the crossover between these two is becoming, well, fibre is quite quickly becoming the go-to solution, isn't it? And it can do a lot of the CO2 stuff.
CO2 traditionally was always the better process for thicker materials, and also materials where the grade wasn't quite as high. It's like a laser cutting grade steel. So fibre is great, and formerly, when in the early days, was brilliant on thin materials. It was good on very high quality materials, and CO2 was better on the thicker ones. As you say, those boundaries are getting a bit grey now. Fibre power is going up. Fibre management, i.e. the optical chain management, the software, the head management and everything, is getting more advanced, and of course that's taking some of the emphasis away on CO2.
Have you seen some of the parts that Barry bought here today, where you can not the ones that have been bent and punched, but the actual grades of the where the laser has cut, or the fibre laser has cut, and it's quite interesting to see that the difference in the surface finishes depending on the.
You've got an example, haven't you? You've shown us the different examples of the different surface finishes. Is that something that's really important?
It can be. It depends on the application. If the part is going to go into something and be hidden, then they might not be too worried about the surface finish. But if it's got some kind of an aesthetic quality to it, or more importantly, it's got to fit into something else and the finish could affect that fit, then of course it's very, very important. And again, looking at the technologies that we're using, whether it's thick or thin materials, you need to have the right technologies on the machine, which is what we have, in order to A, get the best speed, but B, get the best quality as well.
Barry, this is new technology for me, so I'm learning quite a lot as we're going through. Industries, you've mentioned depending on the industries, but where are you selling these and who are buying them?
Anything to do with basically flat metal product and, the automotive side. So, of course, you've got the automotive industry, as we mentioned. You've then got aerospace. It's used in aerospace. You've got heating, ventilation, air conditioning, refrigeration, both commercial and domestic. You've got white goods, you've got yellow goods, green goods, as I like to call them, i.e. agricultural. Literally anything that is made out of sheet metal has got to go through some kind of process.
And this is the thing, you don't think about it in everyday life, but when you go into the supermarket and you see the shelves and everything is made in this way.
Point of sale display.
Point of sale display. It's such a massive industry. I mean, how big is it in terms of consumption? Let's just take the domestic market.
There's some pressure on you. Yeah. We didn't prepare this one, did we?
Well, if you subtract out last year, which obviously is a bit of an anomaly, you've got a good number of laser machines going into the industry across different sectors and different applications.
I mean, how many shops would you say there are up and down the country that might have, maybe not just yours, but a technology that is a laser cutting technology?
Hundreds, probably thousands. There's a lot of them.
Really?
It's quite surprising when you go out there and actually look. You only need to Google, laser cutting specialist or something like that. It's immense.
And sorry to ask as well, but north, south, is there any areas of industry that work equally
fairly
divided?
even spread, but it depends on what's clustered around them as well. So you'll find around the Midlands, for example, you're going to have more automotive supply chain.
Yeah.
And what would be a typical automotive part then? You mentioned industries, but let's dig into.
If you wanted to look at automotive, so basically you've got the underneath the skin of the car, so the frame structure. That could be the door structure, it could be the inner wing structures, the shell of the car. You've got things like the radiator grills, you've got assembly components, bracketry, all those sorts of things. It's not just looking at flat product, because you've got other things that are in there that start life as flat but then become bent.
Yeah.
So that opens up a whole new arena of other components that also go through the same technology. And one of the things you find, particularly in the automotive industry, is they will design out weight in order to maintain fuel economy or increase fuel economy and more efficiency from the vehicle. One of the things they have done is gone down the route of hot stamp parts, where they go now with a thinner material and stamp it under a temperature in order to get the form, and then laser cut it out rather than use a thicker material to get the same structural strength.
Right.
Wow, incredible. Now, coming up, we're also going to be talking punching technology, bending technology, and additive manufacturing. But before we move on to punching, Barry, just tell me about this new machine you've got, this Laser Genius Plus.
The Laser Genius Plus. Okay, well, basically that's where we have now designed the next level of 2D laser cutting, i.e. our next machine, the next generation of machines. But we haven't just evolved a previous model. We've kind of, I won't say started again, because we already know, that technology, but we've looked at what our customers wanted. We've looked at what is going to benefit them and where the industry is going, and then designed from that principle. So we have, of course, a new styling principle behind it, but we've also optimized the footprint of the machine. So it's a very, very narrow machine. The components are integrated inside it. When I say components, things like the laser generator and the chiller, they're all built into the machine's body now rather than being a separate standalone item. That means the machine can fit better into a factory environment. We've made this particular model now reversible so that you can load from one side or the other depending on what the factory requirements are. Then when you drill down deeper into the technology, we've optimized things like the feed, the acceleration of the machine to get the best possible performance out of it. The head is our own head. It's an adaptive head, which we've had on our lasers for quite some time now. So that adapts itself to the different material thicknesses that we put through it. And basically, it means no operator involvement whatsoever. So it's just a case of putting in the material thickness. And the machine sets itself internally in its head. The head itself has been now optimized and improved. Better cooling, better cleanliness. All to make the process itself as efficient as it possibly can be. And then we combine that with our software and our technological suites to basically give a solution that is able to cover a wide range of different applications on one machine.
So someone listening to this podcast who should be interested in the Genius Plus model?
So basically anybody that is in the sheet metal industry that's looking for a 2D flatbed laser, the thing with that machine is that it's designed for, as we've said earlier on in some of the technical corners, it's modularity. So you can take a standard 2D laser, that's just a laser with a palette changer, or with an automation level, or a mind on automation later on. It suits all of those environments perfectly. So anybody that's subcontract or specific manufacturing of a particular part or a particular sector, it suits all of them.
And okay, we're going to come on to punching technology now, but I'm sure there's more details on your website if people want to see the Genius Plus. Now, Lyndsey, have you ever seen one of these punching machines in action?
Yes, I have actually, but I know that didn't you go out to an exhibition?
We went to Blech, I think it was Blech Expo or one of the two. I can't remember.
Yes.
It was Blech Expo, yeah. And you might have seen a video done on that or done on these machines. Correct me if I'm wrong, Barry, but some of these punching technologies up to 1,000 punches per minute, depending on the part, isn't it? The first thing that strikes me when I look at the technology you're offering on punching, how fast the machines are. I mean, it's just out of this world. I've never been massively into sheet metal fabrication. When I was an engineer, I was always turning, boring or milling. So I'd never had too much involvement in that side. But these machines can't have been punching this fast for very long because...
No, where that's really come from is the development, particularly on our side, on the servo-electric side of things, because servos are very predictable, very programmable. You tell them to go to a position, they go to that position, and they do it very, very quickly and very efficiently. So that's one of the ways we've managed to achieve that kind of a speed. Of course, it depends on how far the holes apart are, all that sort of thing, but we are able to now move the material on the machine very, very quickly into a very accurate position without needing to slow down to achieve the final position. It's just there, and the ram is striking straight away. And
but
of course,
you've
that's
evolved with
as well.
The tooling side and everything.
Yes.
The stories that you've told us today about the tooling, and you can have 20 tools, but then in part of the tool carousel, you can have 4 within those, and then some are moving, some aren't. It's like when we talk about tooling and driven tools, it's almost like it's gone to the next level.
It has, yeah. So basically, our punching machines work around a turret principle. It's a rotary turret with multiple stations in it, either 16 or 20 on most of the machines. But within those positions, we're able to put effectively another mini turret. So we can then put, for example, a 24-station tool in a turret and rotate it. So instantly you've added another set of tooling in that one position. You do that all the way around the turret, suddenly you've populated that machine with a heck of a lot of tools. Some of those tools can then rotate, others might not need to be rotated, some can be forming tools, some can be punching tools. We can tap with it. There's just a huge array of different things we can do on one platform.
And what you're saying is basically people who thought of punching technology before needs to really get reintroduced into it now because of where you are with it today.
Absolutely. Yeah, I mean, the machines themselves have evolved. Forming has always been something that could have been done on a punch, but it's the level that we can now go to with the forming. For example, a louver is one that I always like to mention. So that's the kind of the grill you'll get on a ventilation on your microwave, for example, something like that. If that needs to go in a radial fashion, not just in a straight line or be at a different height, you don't necessarily need to have one tool for every one of those different sized forms. It's the same tool, it's just how far we push it through the material and at what angle we set the tool. And that's come as a result of the way that we have the technology set up on the turret with the indexable forming and the fact that we can actually do that in the turret in the first place.
I wonder whether you make parts for the back of dishwashers, which means they can eradicate foam and stuff when people...
Sorry, Paul, why would someone have foam in their dishwasher? Would they be like you who put fairy liquid in it?
Maybe a mistake
twice.
I made. Yeah, twice now.
Twice.
This really is, I think, what you say, Lyndsey, about reintroducing yourselves into this technology is important because I've seen the machine punching and I've seen it doing some of the other operations I'm going to mention, but it's almost endless really because you're forming, roll forming, engraving, marking, tapping. It pretty much does everything as well as laser cutting.
Yes, yeah. So certain parts sometimes will have a contour or a form on them that doesn't lend itself to being punched. It could be a large arc or something like that on the outline or indeed inside it. That is perfect for being cut on a laser, but of course a laser can't put a tapped form or an up form or something like that on the sheet. So what we have there is we use the same basic underpinning technology from the punch, and we have a laser head on the same machine. It might also be that we don't want to do that, but what we want is a lot of very square, straight edge parts coming off the machine in high volume. In which case, we don't put a laser on it, we put a right angle shear on there, 1 metre by 1.5 metre right angle shear that just chops the parts out once they've been punched and formed, and literally they go on to the next process.
How big are these machines, Barry? We're going to get into bending technology very quickly, but punching and laser, how big do these machines go?
So we normally, I mean, it's based around sheet format. So normally, a smaller machine is going to be 1.25 by 2.5 meters. We do 1.5 by 3, 1.5 by 4. On the laser, we can go up to as big as 2 by 6 at the moment.
Okay, that gives you the listeners a good overview of the sizes of machines. Okay, bending technology next.
Again, now, another technique you're really good at, Paul.
Yeah, that's right.
Punching, bending.
Punching and bending, yeah. Hydraulic press brakes is what I've learned today from our technical corners is really the difference between the panel benders and the hydraulic press brakes. Maybe that's a good place to start.
Yeah. Okay, so we have the hydraulic press brakes, as many manufacturers do, but the hydraulic press brakes for us are more for heavy engineering. So we will put those into the yellow goods industry, into, sort of screen crushers, anything where we're doing thick materials that need a lot of bending force. And also the other thing with the hydraulic machines is sometimes you might want to tandem them, i.e. put 2 press brakes together to bend a very long part. We can do that with the hydraulic ones. Does it not affect the strength of the material if you've got a big thick plate that you're bending when that radius is created? Does that have any effect on you've got a few things that you have to watch for. So across the length of the bend, you can get, especially on a long bend, you can get what's called crowning, where you will get a different deflection in the middle of the material to what you get at the end where the forces are. So on most sort of conventional hydraulic press brakes, you may need to have CNC crowning, where you're basically applying a slightly different force in the centre in order to get a consistent bend. On our other press brake range, which is our servo-electric machines, they are an enclosed O-frame structure. So because they're an O-frame and not a C-frame, the structure of the machine doesn't open up because it's closed off at each end. And that means that you get a very consistent bend. You don't get the deflection in the middle that you would get from a C-frame type hydraulic bending machine, because everything is controlled and the force is very evenly distributed across the bend. We still do have CNC crowning for customers that want it on the long machines on the servo-electric, but it isn't always necessary. What you get with the servo-electrics, again, because it's servo-electric, the machine just goes wherever you tell it to go every single time. No variances in hydraulic oil viscosity and performance, leaks or anything like that. It's very predictable and very low energy. And the servo-electric is a much better solution in a lot of senses, isn't it, across the board? Yeah. I mean, even from the point of view of energy consumption alone, I mean, the one thing that everybody associates hydraulics with is that when the hydraulic pump is running, it's using energy, even if the machine isn't actually doing anything. And yes, you can get eco machines. Our hydraulic machines don't necessarily have the pump running all the time, but you have still got an energy consumption there that you just don't have with servo electrics.
I want to move on to the panel benders, because this is another area of watching some of the videos we did earlier. I do recall going to shows and seeing again these machines in action. They are the next level again, aren't they? Once again, in terms of creating a finished construction from one sheet.
Yeah. The panel benders generally will go into either an application with a lower requirement on operators. So they're the more basic panel benders, where literally the operator gives the piece to the machine and the machine will execute a series of bends along one edge. If you take that up a level, it will then rotate the piece and do the next series of bends along the next edge and so on, and then present the finished part back out to the operator. If we go to the full automation level, then literally that machine is being fed by another machine that's further down the chain, maybe a laser or a punch or something like that. It executes the bends. It may even need to flip the piece over before it starts bending them, and then when it's finished bending it, presents the part, something like a draw, for example, or something like that, presents that back out to the discharge area. So all the operator or the next part of the process needs to do is pick the part up and put it wherever it's going.
It kind of brings me back full circle to what I said at the beginning when I said how capable your company and business is at providing the full solution. And that's exactly what you're doing. And you also provide bespoke software to back all of this up.
Yes.
So the whole service that you provide isn't just, right, here's a machine, this does this.
Yeah.
This is what's your end goal. Are you looking to make, one drawer or the whole cabinet? And we can provide you with everything, all the tools you need, and then some. And then you work with tooling suppliers as well.
Absolutely.
And then you bring it all together.
We bring it all together, yeah. That's one of the things that we do very, very well, is that we will go and consult with our customers. Yeah, we sometimes get asked, I want a 2D laser and it needs to be 4 kilowatt and this is what I want it to do. But at the same time, we'll very often get called in and say, look, I am making these parts and I want to go to the next level of production. I need a production line. I need to be able to put in 80 different types of materials loaded into cassettes, so I don't have to worry about storing. Just give me a big vertical multi-station storage unit, big tower system, and I want to do these parts in one process. So yes, it's multiple machines.
But who's buying that? Because I mean, we're plucking examples out, but who are the people who are after the full solution, and then who are the people who are after the singular machine?
So the singular machines generally would go to somebody who is doing lower volume, or perhaps a wide range of different applications that more subcontract. Yeah, low volume, subcontract, one-off, bespoke stuff. You can do, high level production with them, because we do automation solutions that are literally just feeding the machine and unpacking it. The big systems you mentioned, they tend to go into the high volume manufacturers, the people that are doing things, domestic heating boilers, large multi-batch refrigeration systems, things like that, where there's a lot of volume. Dishwashers, yeah, there's your good example again, dishwashers.
Yeah, you might need a new one soon, mightn't
you? There's a lot going on in these machines when you watch the video.
Yeah.
Picking up, placing parts, turning them. How reliable is all this? If you had to, is there a statement of fact that you can say, well, the majority of our machines in a cell will have 98% uptime, or I don't know, is there anything that you talk to engineers about their reliability?
Yeah, I mean, we aim for, absolute maximum reliability, and of course it's going to depend on how well the machinery is maintained. That's the key thing. The machines are designed to run flat out 24/7. That's the aim that we have, because in these high volume applications, any stoppage time is money. And we're aiming to prevent our customers from having to have that. And one of the things that, as I mentioned, is the maintenance side of things, is that we need to have service that is capable of dealing with that. Going back to our origins, we started in automotive. Automotive is, you just don't stop it. The penalties are too great for the customers. So our service has grown up around that ethos, and we use the very, very best of technology available to maintain that service, as well as to offer the biggest range of service products to our customers. So we can easily supply a machine into the industry that has a standard warranty with it, of course, as every machine does, but is then backed up with an extended care package that can last many, many years to cover all of the predictable costs in running the machine and maintain the uptime. That's just part and parcel of what we do. And then we bundle that, as you mentioned, in software earlier on. All our machines are Industry 4.0 standard. They've all got that capability, and we can bundle that with our own software for both programming and scheduling them, but also feeding the data back again into a customer's ERP, SAP system, so they know exactly what's going on their shop floor.
You know what? So it makes me laugh, because you told me a story earlier about it got sold to you because there was someone wearing VR or AR glasses. Yeah. Can you explain to everyone?
Yeah, we've got on one of our videos, you actually see one of our engineers, I think they're in one of the 3D lasers, if I remember correctly, and they are looking at something in the machine. But of course, all we can see is a man standing inside the machine. What he can see, because he's got his augmented reality glasses on, is a whole list of menus and other things that are pointing him in the direction he's looking to tell him what he should be looking for. So we employ all of those things. We have got virtual reality for demonstration things mainly. We've got augmented reality from a point of view of maintenance and support. We have, as I mentioned, Industry 4.0. We're clued into Internet of Things.
I've never heard a company have all of this.
Yeah, we've got all of that.
Not with VR and all of that.
We've got all of those things.
MTD. Yeah, I've never seen it. We'll be tripping up over ourselves if we've got VR goggles
we mentioned the new laser earlier on. That's got an element of AI built into it. From the point of view of its own process management within the head. So all of these new technologies we're embracing. And the other thing, as I think I mentioned in one of the technical corners, is that every one of these technologies, it's a specialism in its own right. And it's not as though we're all, as a global team, focused on absolutely everything and an expert on none of them. Every one of these technologies has got its own in-house set of experts, its own product unit. And of course, they all work together to bring the thing together. But what actually is really, really apparent is that we've got very, very high-end specialists on every single piece of technology in the range, and then other specialists in bringing all of that together.
And that's what takes me on to our last subject here, because there's additive power, isn't it? Which is a company in itself.
Prima Additive, yes.
Prima Additive, sorry, got it the wrong way around. Yeah, Prima Additive. You're now developing and supplying additive technology solutions. Describe what some of these are.
So basically, we have both additive technologies in our range. We've got powder bed fusion and we've got laser metal deposition. The powder bed fusion, well, firstly, the way we've got into this is because we already build lasers. So we know what we're doing with lasers, and of course, additive uses lasers. So we have the powder bed fusion machines, which, as everybody knows, is basically a bed of powder. You fire a laser at it where you want to create the part, you fuse the powder together, and then you build the next layer. With laser metal deposition, it's different. You're spraying the powder at the focal point of the laser, fusing it together on top of the part you're building. So for the two different technologies, we've got different machines. We have bespoke machines for powder bed fusion. And then on the laser metal deposition, this is a 3D laser application. And we already build 3D lasers. So what we've actually done is brought that technology onto our 3D lasers. So where our 3D lasers before could have drilled, which we use quite often in the aerospace industry, very, very small hole drilling using a laser, or cutting or welding, well, we can now add additive to that as well, because it's done on the same platform, but just with an additive head. And we can do that all the way up to our very biggest 3D machine, which is a 2 metre by 4 metre by 1 metre machine.
You've been seeing quite a few additive manufacturing stories lately, haven't you? It's a popular process that's becoming much more adaptable and diverse.
It was quite interesting when we did a student talk the other day when I said about 3D printing, say that's kind of side skirting it, but about 30% of the students in the room said that they had 3D printers. So if that's the case there, imagine on a commercial point of view, perspective, how much more this area is growing. And when I hear from you talking about it, what I see your USP is the size of the products. When we're talking about 3D printing and everything like that, additive manufacturing, a lot of it is smaller machines, but you're talking about beds.
We're able to cascade the technology right the way up onto the biggest 3D laser that we do.
Yeah.
And generally speaking, that might not be for building an entire part on that sort of size, but certainly for repairing high-end fixtures and components or building or adding to, that's definitely where that comes in. But the other thing to look at is with the additive technology itself, as I'm sure you've seen, is that from the point of view of the automotive industry, for example, we're talking about green technology, we're talking about circular economy, where we are trying to reuse materials rather than create new materials, trying to design out weight where we don't need material. That all
I find
comes
that quite
into
interesting.
Yeah.
When you see the honeycomb centers within your additive, you never ever could have worked on that type of technology, and because you're creating those honeycomb centers or whatever the technical term is, you're losing the weight, and isn't that just fascinating? You could have never even accessed that part before, and that's
one area
fascinating.
that I find really impressive about this is the fact that you can start to design a part. Let's say there's certain areas of a part that have extreme wear and need very hard wear-resistant materials, whereas other parts of that particular application don't need it, but would be better if they were lighter. So you can then start bringing these materials together in order to create the perfect part.
We're refining every single process by taking on technology like this.
Yeah, and as we go forward in terms of the technology that we're having to take into the future because of, you know, the environment and everything else, all of these things matter. All of the low energy consumption, the low material consumption, the taking the weight out of things. You think of a car, for example, a battery electric car is going to perform much better with a lot of weight taken out of it. So all of these things have considerable implications.
So here's the question for you, Barry, and we're going to wrap this one up shortly. It's been a brilliant hike. In fact, we've gone well over the half an hour mark. When you look at additive, there's a cost associated with the machine, there's a cost associated with the materials, there's a cost associated with doing the process. Where's the balance between whether it becomes cost effective to do it, and how do you work out what's right and what's wrong?
It's a little bit of a difficult thing to work out in terms of just off the cuff. You have to look at the parts, you have to look at the production quantities, how many of these things do you need to make, because additive is not always as quick as machining a part. It's getting faster, but of course, if you've got to make tens of thousands of these things, you've got to really think about how you're going to do it. The one thing with having a larger additive machine is that you may be able to produce multiple components all in one go. But again, you've got to look at a balance between volume and the production requirements and the performance of the part. You know, there are some parts we've just said that you couldn't make any other way because additive lends itself into that kind of a process. That's when our experts basically have to sit down and really look at it. And that's what we do with all of the additive solutions we do. It's very consultative. I mean, to be honest, with all of our product range, it's very, very solution oriented. Yes, we have standard machines. Of course, they underpin everything. But we always work with our customers to determine the very best solution for them, not just for now, but for the future. Whether they're looking at a 5-year investment, a 10-year investment, 20 years, whatever it might be, we're looking at the whole picture and not just what they actually want at this point.
Brilliant podcast. 2 last points from me before we finish this. In 2012, you were responsible for the manufacture of the Olympic torch.
Yes,
right?
That was done on our machines, by one of our customers, yes.
Cool.
Yeah.
So if you see that on the internet, you can see that that's been made on one of your machines. Second and final point, are you related to Wayne?
No, not that I know of.
Brilliant. Well, that's probably the least important question, or least important answer we found out.
I definitely don't have his ears, that's for sure.
He's listening.
Barry, thank you very much for joining us today on this podcast. You can obviously contact Barry by searching up on the internet Prima Power or Prima Industries, and you'll be able to contact Barry here, who covers the UK. There's also some technical corners coming to the channel very soon, which will be on YouTube, so keep an eye out for those. Thank you very much for your time, both of you. It's been a terrific day. Thank you.
Thanks for listening to the MTD podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on mtdcnc.com.